Okay, welcome to section 8.2. We're going to do a little review of angles and polygons. We'll do a review of the different types of polygons first, and then we'll talk about the interior angles and exterior angles of polygons today. So this should be a review for you from your geometry class. We'll take volunteers. We'll do 3 at a time just to review the different types of polygons here and classify them by the number of sides. So volunteer to come up first. Keaton. Why don't you come up? Why don't you do the first 3, Keaton, and then we'll let somebody else do the next 3.
All right.
And somebody else do the following 2. So whichever ones you feel like doing there,
Okay.
just click and drag it over. Quadrilateral was a four-sided polygon. That's what Keaton says. Keaton's going for the easy ones here. You're all the way over. There you go. Triangle was the 3-sided polygon. So one more here.
Let's do this one.
And the 9-sided polygon is the nonagon. Looks like you got a pretty good start on our little review project here. Next person, Carly. Come on up. Why don't you do 3 here, Carly? The decagon is 10-sided polygon. Sounds pretty good. Pentagon for 5 sides. And an octagon for 8 sides. Okay, Carly? Think we're getting them right so far? Pretty good. One more volunteer, and we'll do the following 2, and we'll also check to make sure we're doing it right. So, Kenny, go ahead and come on up. Got a 6-sided polygon and a 7-sided one. We left the hard ones for you. Hexagon and heptagon. Okay, go ahead and hit check, and we'll see. All right, we got them all right. Good job. So, review over polygons. One more time, you have your 3-sided polygon as a triangle. 4 sides is a quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7 sides is a heptagon. 8 sides, octagon. 9 sides, nonagon. And 10 sides is a decagon. That should be review for you. The next thing that we're going to do then, we'll move on to the theorem that we have with this section that says the sum of the measure of the interior angles of a convex polygon with n sides is. So this is a formula that you do need to know. We'll erase here, and as you can see underneath the eraser was the formula n minus 2 times 180. So you can go ahead and fill in your sheets with that formula. Remember, convex, there's no sides that are caved in. A convex figure is a figure with no dents inside of the figure. So we'll use this formula n minus 2 times 180, where n represents the number of sides. So let's take a look at the practice activity that we have here. There's 2 things that you need to find. I'd like you to go through and take a minute to find the sum of the interior angles of a hexagon, and also the sum of the interior angles of an octagon. From our discussion a couple minutes ago, you should know hexagon has how many sides? 6 sides. And octagon has how many sides? 8. So that's your n value in the formula here. So go ahead and plug those in. And let's see if we can find the sum of the interior angles of each of these polygons. What I've done here is I've created a little pull tab under the box that I've asked you the question on. So Brian, you want to come up and pull down the pull tabs, and we'll see if we ended up with the correct answers here for the sum of the interior angles of a hexagon and an octagon. Just pull her down, yeah? Okay. So in the hexagon, we found the sum of the measure of the interior angles to be? 720. Everybody come up with 720?
Yep.
Outstanding. Let's try the octagon here. Sum of the interior angles of an octagon, 1080, correct? Good work, Brian. So now we talked about the different polygons. We've talked about the sum of the interior angles. What we also want to do here is we want to look at what it means to have a regular polygon. A regular polygon is a polygon in which all the angles and all the sides are congruent. So notice here you have, what type of figure?
Octagon.
Octagon, kind of like a stop sign, right? An octagon. So if it's regular, that just means that all the angles are going to be congruent and also all the sides are going to be congruent. The same length, right? Same measure, same length. So here's another type of problem that you're going to have in your homework. Find the value of x in a regular pentagon. Okay, a regular pentagon. Well, the first thing we need to do is we need to find the sum of the interior angles of a regular pentagon. In a pentagon, we have 5 sides, correct? So what I need to do is I need to find the sum of the interior angles as 5 minus 2 times 180 degrees. We have our calculators to help us out with that. So by calling up the calculator here, we would type parentheses 5 minus 2 close parentheses times 180 degrees. And we see that the sum of the interior angles of any pentagon is going to be 540. So the sum is 540 degrees. Okay. Now if it's regular, what does the word regular mean? Emily? Regular means what? A polygon with all angles and sides congruent. Well, we're talking about the interior angles here, so if this angle is 3x, this angle here should also be 3x, 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 and 3x. Because in a regular polygon, all angles and all sides are going to be congruent. So if I add up the sum of these interior angles, I know they're 540 degrees, or in terms of x, how much would they be? Drew? In terms of x, we'd have 3x plus 3x plus 3x plus 3x plus 3x gives me 15x. 15x. So I'm going to then go to my equation. Instead of s equals 540, I'll have 15x equals 540. Let's call our graphing calculator back up here. And we'll take our answer for 540 and divide it by 15.
36.
Oops. There. 540 divided by 15. And as you can see, it does turn out to be 36. So in this example, x equals 36. Okay? So that is the interior angle idea and the sum of interior angles, and then we involved a regular polygon along with this. Exterior angles. The sum of the measure of exterior angles of a convex polygon is always going to be 360 degrees. So go ahead and write that on your sheets there. Exterior angles will always add up to 360. Here I'm still looking at a pentagon, right? See my pentagon here? 5 sides. Each one of these is an exterior angle, colored with blue, orange, green, purple, and a little bit of a light shade of red here. What I want to show you is that they do add up to 360 by using something that you already know. If I take angle 1 here and put it into my chart, angle 2, that's the second exterior angle. Angle 3 would be your third exterior angle. Angle 4 would be your fourth exterior angle. And angle 5, your fifth exterior angle. Notice that it makes a complete circle. How many degrees are in a complete circle? 360 degrees. So here I'm showing you that the 5 exterior angles, when I put them next to each other, will turn out to be a complete circle, or prove to you that the exterior angles of a convex polygon will always be 360. Okay? So that's it for the lesson. We'll go over your homework in just a minute.